Okay, so I'm continuing. So this is the part two of the component and individual mass balance. So the idea of the component of individual mass balance comes from this concept. So we are dealing with two things here. We are dealing with mass balance and what the weight of an individual. Because we are balancing the mass, so we have to balance the mass of water. We will start with the water. You can see here water. So we have to balance the mass of water from here, mass of water from here, then we equate that one, sorry, then we equate that one from what? From the output, from here, this is the M3, and also here. So we know the M3 is what? 23, so it's 23 here. Okay, so we are going to use this idea to deal with our problem. So if we know fraction is simple weight over total weight, so if we want to calculate the weight, it's simple by cross multiplying. So the weight is simple fraction multiplying by the total weight. So I represent my weight to be what? Mi is equal to the xi, which is the fraction multiplied by the total weight. So so simple. Balancing mi from here, mi from here, mi from the output, and mi from what here. So this is what I'm doing. So it's simple adding this and that, this, this, this one, and this one, equating this one and this one. So in that we call it to be what? Our component mass balance. So which means I'm balancing mi from what? Input is equal to mi from what? Output. Then from this I try to look at the mixing value, so then I calculate what is mixing. So I'm starting from what? From water. So let's begin with what? Water. Okay, so we are beginning with water. So as we know, our m in is simple m out, and we will start with water, that of water here. So it will be mi water, and mi is simple what? Si multiplied by total mass. So it's m1, which is the total mass, multiplied by the fraction of water from that one. That is what? The stream 1. And I will add that one to the stream 2, this one from 2, which is m2. So I'll calculate the weight of water from that one, which is simple m2 multiplying the fraction of water from that. Then I'll equate that one to m3 plus m4. So we know the m3 is pure water, so there's no salt. The salt is 0. So everything from that one, from that stream is what? Is water. So it's simple m3 multiplied by x1, which is our fraction of water from that, which is 1, as we know. So we know our m4, then we don't know our fraction of water from here. We don't know this, so we are calculating for this. Okay, so we know our m1 to be 20, multiplying by the fraction of water from that, which is 0.6, plus our m2 15, and the fraction of water from that one is what? Is zero point 0.4. Good. So it's zero point 0.4. Then we equate that one. Our m3 is what? 12, I think. Yeah, it's 12. So 12 multiplied by the fraction, which is 1, which is 100% water. So we write 1. Then our m4 here is 23, because we have already calculated here to be 23. Then we don't know the fraction of water from that. We don't know. We are calculating for this fraction of water from here. We don't know. So x1. So 20 divided by 20 multiplied by 0.6 is 12. Then 15 multiplied by zero point 0.4 is what? 6. So 15 multiplied by zero point 0.4, which is the fraction of water, is what? 6. Then we equate it to 12 plus 23 x1, the big x1, which is the water. So 6 plus 12 is what? 18, equal to 12 plus 23x1. Good. So we subtract 18, or we subtract 12 from both sides. So it will be 18 minus 12 is equal to 23x1. So 6 here, right? Good. Then it's equal to 23x1. So our x1 is simple 23. No, it's simple 6 divided by 23. Right? So it's 6 divided by 23, which is 0.261. Very little. So our fraction of water from the M4 is what? 0.261. Okay. So now we know the fraction of water from here is what? 0.261. We have to calculate for that of salt from this string. So it's simple. I can use the I can use this formula and calculate, which will be very long, or because it's only two components from this. So if I know the other one, I can simple subtract that from one, because two things adding up, the percentage or the fraction is what it will be 1. So if I know m1 plus m2 to be 1, simple, I can say 0.261 plus m2 is equal to 1. Then simple, our x1 or our x2 is simple 1 minus 0.261, which I think 1 minus, so it's simple, our x2 is simple 0.789, simple as that. So this one is the fraction of water from the M2 M4, simple 0.781 789 789, simple as that. So this is how we calculate the individual or the component mass balance of our individual component using mass balance, or simple by the application of mass balance. So see you next video. In my video, or I've already done videos using Python to do this kind of problem, so you can check it out to get your hands on how to use Python and MATLAB to deal with this kind of problems.